All right, today we're looking at section 10.5. We're going to be solving quadratics using the quadratic formula. All of our solutions today should be real solutions. In other words, we should not get any negative numbers under our square root, right? So first of all, let's write down the quadratic formula. So the quadratic formula looks like this. X equals negative b. I'm putting parentheses around everything because it just makes less mistakes when you're working on it. Plus or minus the square root of the discriminant all over 2 times a. Now our discriminant, as we found out last time, is equal to b squared minus 4 times a times c. Now I found that if you do calculate the discriminant first and then plug that discriminant into the larger formula, there are a lot less mistakes that happen. So let's remind ourselves also, if I have a quadratic formula in standard form, it should look like this: ax squared plus bx plus c equals 0. So every time you're working on one of these problems, you first need to make sure it's in this form where x squared comes first, x comes second, then we have our constant term, and then the other side of the equation is equal to 0. So we want to make sure it looks like that before we find our a, b, and c. So on number 1, excuse me, number 1, a is equal to 5, b is equal to negative 7, and c is equal to negative 108. Now the quadratic formula is a formula that we can use to solve any quadratic. So even if it's not factorable, even if we can't solve it using the square root method, remember we can only use the square root method if this middle term b to bx is missing, or if b is 0, we can use square root method. We can only factor it if we can find a number that multiplies to a times c and adds to b. So if we can't do either one of those, we can always use the quadratic formula. The quadratic formula will work for any quadratic, so even the ones that we can solve by factoring or square rooting will still work here. All right, so the first one we want to do is find our discriminant. So that's b squared, so negative 7 squared, minus 4 times a times c. Okay, so 7 squared, negative 7 times negative 7 is 49. I'm going to go ahead and put this other part in my calculator. So if I have negative 4 times 5 times negative 108, that gives me plus, because I have a negative times a negative here, so plus 2160, which is equal to 2209. So this is just the discriminant. Now we need to take our discriminant and we're going to plug it into this bigger formula. So negative b, and my b is negative 7, plus or minus the square root of that discriminant, all over 2 times a, and a is 5. Okay, so if I have a negative 7, that's going to become a positive 7, plus or minus the square root of 2209. I'm going to hurry and put that in my calculator. So square root 2209 is equal to 47. So I got 47 over 2 times 5, which is equal to 10. So remember, this plus or minus just means that there's two different solutions. One of them is going to be 7 plus 47 over 10. One of them is going to be 7 minus 47 over 10. So I can just go ahead and calculate each of these separately. So 7 plus 47 is equal to 54 over 10. These are my x values, right? And 7 minus 47 would be negative 40 over 10. So now I'm just going to reduce each of these fractions as much as possible. So 54 over 10 would reduce to 27 over 5, just reducing them both by 2. And then 40 over 10 would reduce to negative 4. So here are my two solutions. Remember, every quadratic has two. So remember, if you have that plus or minus in the middle, that just means I have two different equations that I have to then simplify. One with a plus in the middle and one with a negative in the middle. It's just kind of a condensed way to write it. All right, so let's try number 2. So on number 2, my a is equal to 1 because I don't see anything in front of a squared. My b is equal to -2, and c is -99. So let's go ahead and plug those in. So remember, first you just want to find the discriminant. So the discriminant here is it's b squared minus 4 times a times c. So -2 times -2 is 4. And then if I have -4 times 1 times -99, that's equal to 396. And because it's a negative times a negative, again, it becomes plus 396. So my discriminant here is 400. Now I'm going to go ahead and plug it into our bigger formula here. X is equal to -b, and b is -2, plus or minus the square root of that discriminant that we just found, which is 400, all over 2 times a, and a is 1. So now I'm just going to simplify each one of these pieces separately. -2 becomes +2. The square root of 400 is not a perfect square, but remember 400, I can break that down. This is 4 times 100. It is a perfect square, isn't it? Square root of 400 is equal to 20. Yeah, sorry about that. So 20 times 20 is 400. So the square root of 400 is 20, and then over 2. So now we break it into two problems. We have 2 plus 20 over 2, and we have 2 minus 20 over 2. So 22 over 2 is 11. There's one of our solutions. And negative 18 over 2 is -9. So there's our other solution. So x equals 11 and -9. Okay, let's try another one. Let's skip down here to number 5. Here we have, well, you know what, actually, before we do that, let's do number 3. So on this one, we have x squared minus 9x minus 7. So here my a is equal to 1, b is -9, and c is -7. I'm going to find my discriminant, which again, remember, is b squared minus 4 times a times c. So -9 squared minus 4 times a is 1 and c is -7. So 9 squared is 81. And I have a negative times a negative again, so this would be plus 28. And 81 plus 28 is 109. So this gives me, and then I'm going to put this in the bigger formula, which remember was -b plus or minus the square root of the discriminant, all over 2 times a. So all of b is -9, so -9 plus or minus the square root of 109 over 2 times a. So this would be 9. Okay, now 109 is not a perfect square, so I could go ahead and divide that. Just one second. So 109 is actually a prime number, so we're going to have to leave it as 109 and then over 2. So in this case, our square root did not go away, and because of that, we can't actually calculate this unless we use a decimal approximation for the square root of 109. But I actually do want you to keep your answers in exact form. And so because we can't reduce the square root of 109, our answer will just be that x is equal to 9 plus the square root of 109 over 2 and 9 minus the square root of 109 over 2. You would just leave your answer like that since it didn't reduce. Okay. So I'm actually going to pause this and switch out number 4. We're going to do a different problem. Just one second. All right, so we're going to do this one instead. For number 4, we have 3x squared minus 7 equals 0. I just wanted to do one here where we don't have all 3 terms. There's that x term in the middle that's missing. So in this case, a would be equal to 3, b is equal to 0, and c is equal to -7. And then you just proceed as normal. We're going to find the discriminant first, which would be b squared. So 0 squared minus 4 times a times c, which would come out to, my 0 goes away, but I still have that 0 minus this stuff. So that negative here and this negative here, when I multiply these, will cancel out. So I just have 4 times 3 times 7, or negative 4 times 3 times negative 7, which gives me a positive 84. So there's my discriminant. And then when I plug it into my quadratic formula, I've got negative b, which is 0, plus or minus the square root of 84, all over 2 times a, and a was 3. So this would be plus or minus square root 84 over 6. Now 84 is not a perfect square, but remember I can break this down. Any two numbers that multiply to 84 would be 4 and 21. 4 becomes 2 and 2, 21 becomes 3 and 7. So there are two 2's underneath here, so I can bring out a 2. So plus or minus 2 times the square root of 3 times 7 multiplied back together is 21. So I'm just reducing this square root while keeping it in exact form like we've done in the past. So plus or minus 2 square roots of 21 over 6. Now this 2 over 6, I can reduce that part of the fraction. I can only reduce things if they are on the outside of the root, not on the inside. So this 2 times the square root of 21, I can reduce this 2 with this 6 to get plus or minus square root 21 over 3. But like this one, I can't reduce the 21 and the 3 because this 21 is under a square root and this 3 isn't. So I can't reduce that part. So x would be equal to the square root, or sorry, plus or minus the square root of 21 over 3. Okay. All right, so number 5. This one is not in standard form. So in order to get this one in standard form, we're going to go ahead and add 5 to both sides, just so we can get this one side equal to 0. So this would be 4n squared minus 16 equals 0. So now it's in standard form. I have one side equal to 0. I have the n squared term first. My middle n term is missing, and then I've got negative 16. So here a is 4, b is 0 again, and c is negative 16. So if we plug this in, we're going to get, for our discriminant, we're going to get 0 squared minus 4 times negative 16, 4 times a times c. So I'm going to have, again, a negative times a negative, which will make this positive. So 4 times 16 is 256. My discriminant is 256. I would have negative b, so just plugging it into the bigger formula now, plus or minus the square root of that discriminant that I just found, over 2 times a, which was 4. So this would be plus or minus square root 256 over 8. The square root of 256 is equal to 16. So this one's an even root, or a perfect square. So plus or minus 16 over 8, which is the same as plus or minus 2. So I have two x values that make this equation true. One of them is positive 2, and one is negative 2. All right, so I decided to switch out number 6 also. So what we're going to do here is we're going to do x squared minus 4x equals positive 8. So again, the first thing we need to do here is get this into standard form. So we need to move this 8 to the other side by subtracting 8 from both sides so that we have one side equal to 0 and the left-hand side in standard form. So x squared minus 4x minus 8 equals 0. So here a is 1, b is negative 4, and c is negative 8. To find the discriminant, I need b squared minus 4 times a times c, which would give me 16. Again, I've got a negative times a negative, so this will become a plus, and then 8 times 1 times 4 would be 32. So my discriminant is 48. So now I'm going to put it into the bigger quadratic formula. So negative b plus or minus the square root of 48, that's my discriminant, over 2 times a, and a in this case was 1. So this gives me 4 plus or minus square root 48 over 2. I'm going to go ahead and break 48 down. 48 is 4 times 12. So 4 is 2 and 2. So I've got 2 2's. This is 4 times 3. So again, I've got 2 2's. So this is going to be 4 plus or minus 4 square roots of 3, right? For every 2 2's underneath, I can bring one out. So here I can bring out 2 times 2, which gives me the 4. The 3 will need to stay inside. And then this is over 2. So now on this, I can still simplify this fraction just a little bit. Remember, this is my x values. Because 4, 4, and 2, because all 3 of these have a common factor of 2, I can reduce this to 2 plus or minus 2 square roots of 3. Again, because all 3 of these numbers have a common factor of 2, I can reduce each of them by dividing them by 2. Now, if this would have been like a 5 here instead of a 4, then I would not be able to reduce anything, not even this one, because it has to be a common factor in all 3 of these in order to reduce it. So you have to be careful when you're reducing these fractions. I do want you to reduce them as much as possible, but you can only reduce them if all 3 of these positions have a common factor. And then also remember, the common factor or the number out front has to be the one that has a common factor. It can't be the one under the square root, because under the square root, that would be a square rooted number, not the number itself. So you can't compare it to a regular 2. So just keep those in mind as you are simplifying. And good luck today and have a good time trying these out. If you have any questions, please don't hesitate to ask, and have a great day.